Hey everyone, welcome back again. Oh, what's this? Going back to this. So we did chapter 12, which was really interesting. We went through the concept of bigrams and trigrams. Honestly, I don't think there was anything in this that needed to be there. Let me just look. I think Unicode data is the only thing that's like actually Pythonic stuff, whereas everything here is kind of like it's like the big boss of functions and everything else that they've done so far. Because this chapter really didn't need to be there. It's not really CS per se, at least in my opinion. Maybe I'm wrong in thinking about this. So, chapter 13, files and databases. This, I bet, is definitely going to be CS related. So, let's get right into it. Okay, so you gotta. You know, I'm just gonna hit run all. Oh boy, ran all the way to the bottom. Some downloads, some unzipping of some photos. Not gonna pay too much attention to that. Files and databases. Most of the programs we have seen so far are ephemeral in the sense that they run for a short time and produce output, but when they end, their data disappears. Each time you run an ephemeral program, it starts with a clean slate. Other programs are persistent. They run for a long time or all the time. They keep at least some of their data in long term storage, and if they shut down and restart, they pick up where they left off. A simple way for programs to maintain their data is by reading and writing text files. A more versatile alternative is to store data in a database. Databases are specialized files that can be read and written more efficiently than text files, and they provide additional capabilities. In this chapter, we'll write programs that read and write text files and databases, and as an exercise, you'll write a program that searches a collection of photos for duplicates. But before you can work with a file, you have to find it. So we'll start with file names, paths, and directories. I I don't know if they're actually going to do a database or if it's just going to be like, hey, you can use a CSV file as a database. Or maybe they'll do something like SQLite. I don't think they're going to get into Postgres because that would be way outside of the scope of something like this. File names and paths. Files are organized into directories, also called folders. Every running program has a current working directory, which is the default directory for most operations. For example, when you open a file, Python looks for it in the current working directory. The OS module provides functions for writing with files and directories. OS stands for operating system. It provides a function called getCwd that gets the name of the current working directory. So boom, that's pretty simple. Okay. In directories and also called folders, every running program has a current working directory. Yeah, okay, why is that happening? I don't understand why we're doing this, but essentially we're overriding the actual getCwd with a fake current working directory. The result in this example is the home directory of a user named Dinsdale. A string like home/Dinsdale that identifies a file or directory is called a path. A simple file name like memo.txt is also considered a path, but it is a relative path because it specifies a file name relative to the current directory. In this example, the current directory is home/Dinsdale, so memo.txt is equivalent to the complete path home/Dinsdale memo.txt. A path that begins with slash does not depend on the current directory. It's called an absolute path. To find the absolute path to a file, you can use appspath. os.path, appspath, memo.txt. The OS module provides other functions for working with file names and paths. List_dir returns a list of contents of the given directory, including files and other directories. Here's an example that lists the contents of a directory named photos. os.listdir photos, Jan 2023, Feb 2023, March 2023, and notes.txt. The directory contains a text file named notes.txt and 3 directories. The directories contain image files in the JPEG format. Okay, os.lister, baba. To check whether a file or directory exists, you can use osPathExists. You can do osPathExists false. To check whether a path refers to a file or a directory, we can use isdir, which returns true if a path refers to a directory. And isFile, which returns true if a path refers to a file. One challenge of working with paths is that they look different on different operating systems. On macOS and Unix systems like Linux, the directory and file names in a path are separated by a /. Windows uses a /. So if you run these examples on Windows, you'll see // in the paths, and you'll have to replace the // in the examples. Or to write code that works on both systems, you can use os.path.join, which joins directory and file names into a path using a forward or /, depending on which operating system you are using. I believe you can also use pathlib for most of this now. But yeah, this is definitely one way to do it. Later in this chapter, we'll use these functions to search a set of directories and find all of the image styles. F-strings, yay, these are my favorite. I love F-strings. One way for programs to store data is to write it to a text file. For example, you suppose you are a camel spotter and you want to record the number of camels you have seen during a period of observation, and suppose that in 1.5 years you have spotted 23 camels. The data in your camel spotting book might look like num years 1.5, num camels 23. To write this data to a file, you can use the write method, which we saw in chapter 8. The argument write has to be a string, so if you want to put other values in a file, we have to convert them to strings. The easiest way to do that is with the built-in function string. Here's what that looks like, and I am pausing the recording. All right, coming back to this. Sorry if there's a bit of background noise. So F-strings, to write this data to a file, you can use the write method, which we saw in chapter 8. The argument write has to be string, so if you want to put in other values in a file, we have to convert them to strings. The easiest way to do that is with the built-in function string, str I mean. Here's what it looks like. Writer open some file in write mode. Writer write string num years, writer write string num camels, writer dot close. That works, but write doesn't add a space or new line unless you include it explicitly. If we read back the file, we see that the two numbers are run together. Open blah blah blah. Oh wait, what? Oh, that's because, okay. How do I run all above? Is there any way to just run all above? Can I? Runtime, run before. There you go. Just gonna run that again. 1.523. At the very least, we should add white space between the numbers. And while we're at it, let's add some explanatory text. To write a combination of strings and other values, we can use an F string, which is a string that has the letter F before the opening quotation mark and contains one or more Python expressions in curly braces. The following F string contains one expression, which is a variable name. I have spotted num camels camels. I have spotted 23 camels. In num years, I have spotted num camels. In 1.5 years, I have spotted 23 camels. And the expression can contain operators and function calls. Line equals f in round number years, blah, blah, blah. So essentially, like within the curly braces, you can just do standard Pythonic code. Not everything is valid, but a lot of things are acceptable, which makes producing usable, human-readable strings easy. And with that, we can just write that to the file as well. Both F strings end with the sequence /n, which adds a new line character. We can read the file back like this, and it prints it out for us, nice and nice. In an F string, an expression in curly braces is converted to a string, so you can include lists, dictionaries, and other types. 1:1. Here's a list T and a dictionary D. Yeah, so that's those are, you can stir print. Honestly, when you print anything, it converts it to a string representation. And there's actually a special magic function called __string__, where if you define that as part of your class, which jump a little ahead, I think that's in a chapter or two from now. Basically, that will create, that is the function that will be called when you try to print an instance of that class object. There's also a repr, but that's a whole different story. I'm not going to get into that. If an f string contains an invalid expression, the result is an error. Can only concatenate list, not int to list. Yeah, so duh. YAML. One of the reasons programs read or write files is to store configuration data, which is information that specifies that what the program should do and how. For example, a program that searches for duplicate photos, we might have a dictionary called config that contains the name of the directory to search, the name of another directory where it should store the results, and a list of file extensions it should use to identify image files. Here's what it might look like. Bam. To write this data in a text file, we could use f-strings as in the previous section, but it's easier to use a module called YAML that is designed for this sort of thing. The YAML module provides functions to work with YAML files, which are text files formatted to be easy for humans and programs to read and write. Here's an example that uses a dump function to write a config dictionary to a YAML file. So, honestly, like, I'm surprised that they brought up YAML. I'm guessing this is a newer edition of the book. Let's see. Think Python. I'm just going to check out on Amazon, see when this came out. Where is the release date for this thing? Publication date, July 2nd, 2024. Okay, so it's not old. It's like just a year ago, and this was the 3rd edition. Nice, very nice. To write this data in a text file, we can use f-strings as in the previous section, but it's easier to use a module called blah. Okay, we already read through all this. Try import YAML, except import error, pip install PyYAML. Is PyYAML part of standard library now? Typically using a package manager like the pip. I'm sorry, I'm just looking this up. If you were just following along these videos, I set up YAML logging config, exactly what I was describing actually, in my own Python program. So whether or not, let me think about this. So I just wasn't sure because when I wrote it, I just used import YAML. I didn't have to install PyYAML separately, but I'm guessing maybe it was a dependency for something else in FastAPI or a direct dependency of FastAPI. I'm not sure. So this is basically import YAML or otherwise install YAML. And then we write to the config file yaml.dump config writer.close. If we read back the contents of the file, we can use the YAML. We can see what the YAML format looks like. Or like if you're doing this on your own machine, you can just double click and open it in any text editor and read it that way, or in your IDE directly. Readback equals open config file name dot read, print readback, and just reads it out for you. It's pretty simple. Now we can use saveload to read back the YAML file, YAML.saveload underscore reader. So there's a whole reason as to why it's called saveload. How do I put this? Essentially, the older versions of the YAML module just allowed you to load, but because the module itself was very powerful in its capabilities of creating Pythonic objects straight from simple YAML, it was tuned back so that it was, how do I put this? It was tuned back, aka its capabilities to create Python objects was turned off to some extent to disallow malicious code from running. That's why it's called YAML.saveload. And obviously you can write your own loader functions, and there's other loader functions that you can use. So there is a load function, YAML.load, but to give it that, you have to give it a loader object for it to work. The result is a new dictionary that contains the same information as the original, but is not the same dictionary. Config is config readback false. Converting an object like a dictionary to a string is called serialization. Converting the string back to an object is called deserialization. If you serialize and then deserialize an object, the result should be equivalent to the original. Shelf. So far, we've been reading and writing text files. Now let's consider databases. A database is a file that is organized for storing data. Some databases are organized like a table with rows and columns of information. Others are organized like a dictionary that maps from keys to values. They are sometimes called key value stores. The shelf module provides functions for creating and updating key value store called a shelf. As an example, we'll create a shelf to contain captions for the figure in the photos directory. We'll use this config dictionary to get the name of the directory where we should put the shelf. What in the hell is shelf? Open in tab. I've never heard of this shelf. Shelf Python. Shelf module in Python provides persistent storage for arbitrary Python objects behaving like a dictionary where values are stored on disk. It leverages the pickle module for serialization and deserialization of these objects. Key characteristics and usage. Shelf allows you to save Python objects to a file and retrieve them later, even after your program has terminated. Dictionary-like interface. You interact with shelf object using familiar dictionary operations like shelf key equals value for storing and value equals shelf key for retrieving. Keys are always string, while values can be any Python object that can be pickled. Example, lists, dictionaries, custom class instances. Automatic serialization. When you store an object in a shelf, it's automatically pickled and written to the underlying database file. When you retrieve an object, it's automatically unpickled and reconstructed in memory. Context manager support. Shelf objects can be used with statement, which ensures the shelf is properly closed and changes are synchronized to disk automatically. Security. As shelf relies on pickle, there are security implications from loading data from untrusted sources. As malicious pickle data could execute arbitrary code. Concurrency. Difference between pickle and shelf. So I'm curious about this. I don't understand what's the difference. But they operate at different levels of abstraction and offer distinct functionalities. Pickle is a module for serializing and deserializing Python objects into a byte stream. This means it converts Python objects like lists, dictionaries, custom class instances into a format that can be stored in a file or transmitted over a network, and then reconstructs them back into Python objects. Mechanism serializes a single object or collection of objects as a continuous byte stream. When deserializing, the entire byte stream is typically loaded and reconstructed. Use case. Ideal for storing a single object or a small self-contained set of objects where the entire data structure needs to be loaded at once. Shelf builds upon Pickle to provide a persistent dictionary-like interface for storing Python objects. It uses Pickle to serialize the objects and stores them in a key value database, typically a DBM file. Mechanism allows you to store and retrieve pickled Python objects using string keys, similar to how you would interact with it. That means you can access suitable for storing multiple Python objects where you need to access them individually by a key, or when the entire dataset might be too large to load into memory at once. It's particularly useful for creating a simple persistent data store that behave like dictionaries. Okay, interesting. I did not know about this module. Going back to the chapter. I know about Pickle, but yeah. Shelf module provides functions for creating and updating key value store called shelf. An example will create a shelf to contain captions for the figures in the photos directory, config datadir, photo info. We can use os.makeDirs to create this directory if it doesn't already exist. Config datadir exist okay equals true. Os.path join to make a path that includes the name of the directory and the name of the shelf file, captions. I'm just gonna create this file, db file, photo info / captions. Now we can use shelf.open to open the shelf file. The argument C indicates that the file should be created if necessary. db file name shelf. Okay. The return value is officially a db file name shelf object, more casually called a shelf object. The shelf object behaves in many ways like a dictionary. For example, we can use the bracket operator to add an item, which is mapping from a value to a key. In this example, the key is a pass to an image file and the value is a string that describes the image. We also use bracket operator to look up a key and get the corresponding value. Value equals db key value cat nose. Okay. If you make another assignment to an existing key, shelf replaces the old value. Close-up view of a cat nose. Some dictionary methods like keys, values, and items also work with shelf objects. List db.keys, list db.values. Does anyone use shelf as a database? Yeah, Python. I've been storing the data as simple key value pairs in MongoDB, but I've been thinking if the data is not particularly common. Any other way that a full-blown database would typically be used for? Why don't I just store the data in a shelf? Comes with the Python, so you don't need any extra to use it like PyMongo. It also doesn't require any. Looks like shelf would probably be fine for your use case. Okay. Yeah, it's I think for like simpler DB-ish use cases, and maybe you can use some do it for like local testing and stuff like that, or in certain like machine learning things where you want to pick all the trained model or whatever and store that in this manner with other models or something like that. I'm not really sure. List db.keys, list db.values. So basically behaves very similar to a dict. We can use the in operator to check whether a key appears in the shelf, and we can use a for statement to loop through the keys, no problem. As with other files, you should close the database when you're done, db.close. Now, if we list the contents of the data directory, we see two files. When you open a shelf file, a backup file is created that has the suffix .back. If you run this notebook more than once, you might see that file left behind. This cell removes it so the output shown in the book is correct. Okay. os.lister config datadir, captions.db. Captions.date db contains the data we just stored. Captions.dir contains information about the organization of the database that makes it more efficient to access. The suffix dir stands for directory, but it has nothing to do with the directories we've been working with that contain files. Wait a second. I'm just gonna hit runtime run all because I feel like something is not quite right here. Shelf. Okay. I don't understand what's going on, why it keeps running into issues. db.close, as other files, you should close the database when you're done. Now, if we list the contents of the created directory, we see two files. Runtime run before. I'm just going to run everything up to this point and then run this and then run it again because I'm just trying to see what they're saying. Run before. os.lister config datadir. Okay. Has nothing to do with the directories we've been working with that contain file. I'm just gonna Google this. Oh, that's fun. So for those of you at home, I'm basically a little bit confused because they mentioned captions.dat and captions.dir files along with the observation. Suggested discrepancy in the expected file structure or change. I'm trying to get the AI overview to make sense of this for me. Okay. So yeah, this is basically outdated information here. Because the backend used by Shelf has probably changed since this was written. Because as you can see here, it's just captions.db. And that's because of the GNU backend that is, I think, currently standard and default backend for Shelf when you use it. That's my understanding. I didn't go super deep into it, looking into links and stuff, but yeah. So captions.dat. So in those older things, contains the data we stored. Captions.dir contains information about the organization of the database that makes it more efficient to access. The suffix dir stands for directory, but it has nothing to do with directories. Yeah, I don't know why we suddenly have a sort word function over here. Storing data structures. In the previous example, the keys and values in the shelf are strings, but we can also use the shelf to contain data structures like lists and dictionaries. I am having a splitting headache right now, so I am going to drink a bunch of water, guys. Sorry. And I encourage whoever is watching to also hydrate, because water is important. And I also encourage my wife to do the same if she's listening. Doesn't seem like it right now. Maybe she is. Let me see. My wife is very pretty. Oh, she's actually not listening. Okay, fair enough. She's sitting right across from me, and she's all locked into her own thing that she's doing. In the previous example, the keys and values in the shelf are strings, but we can also use shelf to contain data structures like lists and dictionaries. So yeah, this is what we looked up already. Shelf, and it's just a follow-up from Pickle. They're essentially tools for serialization and deserialization, right? With I'm going to actually scroll up to that very specific definition. Converting an object like a dictionary to a string is called serialization. Converting a string back to... Is this the actual formal definition? Formal definition of serialization and deserialization. I don't know if that's a very formal definition. Let's just look that up. Objects created in a format that can be stored, example in a file or database, or transmitted, example over a network, and subsequently reconstructed. This process converts complex in-memory representations of data into a linear sequence of bytes or a structured text format like JSON or XML, making them suitable for persistent. Yeah, okay. That's what I thought, because like what they said was just like serialization is all about converting an object to a string and then back into an object. I'm like, well, that's not right, because not every object can be represented as a string, right? It's just not possible. So yeah, that's neat. Config goes to make this, scrolling back down. So yeah, oh wait, no, we scrolled a little too far. Yeah, storing data structure. So yeah, that's like the value of Shelf and Pickle in general, is being able to serialize more complex Python objects. Storing data structures. In the previous example, the keys and values in the shelf are strings, but we can also use shelf to contain data structures like lists and dictionaries. As an example, let's revisit the anagram example from an exercise in chapter 11. Recall that we made a dictionary that maps from a sorted string of letters to the list of words that can be spelled with those letters. For example, the key OPST maps to the list OPTS, POST, pot, spot, stop, and tops. We'll use the following function to sort the letters in the word. As an example, let's revisit and recall that we made a dictionary from the... Okay. So... yeah, okay, that function somehow got moved. I must have moved it without realizing it. Let's say move down. Yep, there you go. And here's an example. Pots, OPST. Now let's open a shelf called anagram map. The argument n means we should always create a new empty shelf even if one already exists. Yeah, so that you don't want to do in a real database, because then you're just losing that data, unless you know what you're doing. And in some cases, maybe that is actually what you want to do, but yeah. Now, that's generally speaking not the purpose of a database. The point of a database is to be able to store that data so that you can access it and reuse it later. Now we can add an item to a shelf like this, db key equals word. Pots. In this item, the key is a string and the value is a list of strings. Now, suppose we find another word that contains the same letter, like tops. Boom. db key dot append word is wrong. Why? OPTS. Yeah.
Check your message.
Wait, no, wait, no, hold on. Crap.
Check it later.
1 second. I just don't want my messages. Ugh. Sorry about that, guys. So where were we? Why is this? The key is the same as in the previous example, so we want to append a second word to the same list of strings. Here's how we would do it if DB were a dictionary. Okay, why is this wrong? Wait, let's look at it first. Value error, invalid operation on closed shelf. Okay, yeah, because the shelf isn't even open, because we closed it earlier. Oh no, we didn't. It's open right here. Key error. OPST, during handling of another value error, invalid operation on closed shelf. Okay. I don't know what's going on. I think there's something I run later on that might have overrun this. So that's what we're gonna do. Runtime. Restart session. Yes. And then runtime run before. Okay. Let me think about why that's the case. The key error thing was just weird, some weird funkadelic, because like I think I just ran the entire notebook, so somewhere this was updated later on that kind of messed up what it is, right? What I'm trying to look at this point. And this is the problem with Jupyter notebooks. This is why it's terrible. And for a production environment. It's fine for exploring stuff and all that, but really for production is terrible. Kind of decent for ML and DS stuff, but even then, you're gonna want to try and turn your pipelines into scripts. Like Databricks has that thing where you can deploy from notebooks and things like that, but honestly, that's a terrible idea. Terrible. Would not recommend to anyone. Okay. Key is the same as in the previous example, so we want to append a second word to the same. Here's what we do if DB were a dictionary. DB key dot append words appends the word. From, I guess we append it to a copy of the list and not the list that's saved in shelf. Here's the problem. When we look up the key, we get a list of strings, but if we modify it, it does not affect the shelf. If we want to update the shelf, we have to read the old value, update it, and then write the new value back to the shelf. Yeah, okay. That's what I thought. That's exactly what I thought it was. Cool. I'm glad I got that right. So essentially, basically what's happening here is that when you get that Python object from a shelf, you're essentially, can I get one too, please? If there is one. Anyways, basically you get a copy of the list, and to actually put it back in the shelf, you're gonna want to assign it back.
This
Okay.
is for you only. I just wanted a sip.
Oh, thank you.
There is already 2 more sabzis in the kitchen.
What subjects?
दो pause कर दो 1 second.
Alrighty. Getting back to where we were at. Sorry about all the repeated distractions and stuff. It's just a lot going on today. So yeah, going back to this, basically when you call the shelf, Pythonic object just returns a copy of that object, and if you want it to actually be saved back into the shelf, you have to assign it back. Now the value in the shelf is updated, and as an exercise, you can finish this example by reading the word list and storing all the anagrams in a shelf. I am not going to do that. Checking for equivalent files. Now let's get back to the goal of this chapter, searching for different files that contain the same data. One way to check is to read the contents of both files and compare. If the files contain images, we have to open them with mode RB, where R means we want to read the contents and B indicates binary mode. In binary mode, the contents are not interpreted as text, they are treated as a sequence of bytes. Here's an example that opens and reads an image file. Type data1 bytes. The result from read is a bytes object. As the name suggests, it contains a sequence of bytes. In general, the contents of an image file are and are not human readable. But if you read the contents from a second file, we can use the equals operator to compare. Data1 equals data2, false. These two files are not equivalent. Let's encapsulate that we have so far in a function. Boom, okay. So this is basically checking the first file, checking the second file, and comparing them. If we have only 2 files, this function is a good option. But suppose if we have a large number of files and we want to know whether any 2 of them contain the same data, it would be inefficient to compare every pair of files. An alternative is to use a hash function which takes the contents of a file and computes a digest, which is usually a large integer. If 2 files contain the same data, they will have the same digest. If 2 files differ, they will almost always have different digests. The HashLab module provides several hash functions that the one we'll use is called MD5. We'll start by using HashLab MD5 to create a hash object. Yeah, so the hash object provides an update method that takes the contents of the file as an argument. Okay. Oh, data1 is not defined. Okay, wait. I'm going to runtime. Run before. Now we can use hex digest to get the digest as a string of hexadecimal digits that represent an integer in base 16. Boom. The following function encapsulates these steps. Boom. Yeah, this is pretty standard stuff. You can also use like hex digests for all kinds of other things. One way I used to do them um, was I used it to create like unique IDs for a database. Though in retrospect, something like a UUID v4 would have been better. Um, anyways, but that's another potential use case for getting the MD5 hash of an object or a file or whatever. If we hash the contents of a different file, we can confirm that we get a different digest. Now we have almost everything we need to find equivalent files. The last step is to search the directory and find all the image files. Following function takes an argument the directory we want to search. It uses listdir to loop through the contents of the directory. When it finds a file, it prints the complete path. When it finds a directory, it calls itself recursively to search the subdirectory. Boom, so it just walks. I think there's an OS path walk option as well. Oh yeah, def walk. That's, I think you don't need to use that. You can, I think OS gives a walk module that you could use, but I think this is just to showcase how recursion works and help people reinforce that. You can use it like this, walk photos. The order of the results depends on details of the operating system. Okay, we're almost done here, boys. Debugging. When you are reading and writing files, you might run into problems with whitespace. These errors can be hard to debug because whitespace characters are normally invisible. For example, here's a string that contains spaces, a tab represented by the sequence /t, and a new line represented by the sequence /n. When we print it, we don't see the whitespace characters, no way. The built-in function repr can help. It takes any object as an argument and returns a string representation of that object. For strings, it represents whitespace characters with / sequences. This can be helpful for debugging. One of the problems you might run into is that different systems use different characters to indicate the end of a line. Some systems use a new line represented first /n, others use a return character represented /r. Some use both. If you move files between different systems, these inconsistencies can cause problems. File name capitalization is another issue you might encounter if you work with different operating systems. In macOS and Unix, file names can contain lowercase and uppercase letters, digits, and most symbols, but many Windows applications ignore the difference between lowercase and uppercase letters, and several symbols that are allowed in macOS and Unix are not allowed in Windows. So, yeah, that's a whole thing about file consistency. It causes weird small bugs. That's why the most like Python formatters like rough, etc., force a new line at the very end, just to make it compatible across multiple devices. Because I don't know whether it is in Windows that it ends at the very last character, or it automatically gets an additional new line. It's whether that's Windows or Unix, I don't remember, but that's just how files operate. And so that can cause some small weird issues and phantom changes in your code base. Yeah, and just generally the whitespace stuff, just knowing these characters and knowing that they can cause things is good to know. And knowing about repr is also nice, because repr specifically creates a string representation of the object. Str also does that. But the goal is that repr will create, and this isn't always the case, but the goal is that repr of an object can actually recreate. If you do eval, so if I did this, eval, and print it. Okay, runtime run before. Yeah, so if you do eval repr s, it just recreates the original object. And that is actually the intent of repr, is that it creates a very specific type of string representation that you can literally reevaluate to create the object. Now, that is the goal in practice. Now, that is the goal in theory, but in practice, it's not always perfect. But yeah. Here's all of the glossary, the entire glossary, which is really nice, honestly. exercises. Ask a virtual assistant what are the difference between ephemeral and persistent programs. What are some examples of persistent programs? What's the difference between relative and absolute path? YAML module have functions like load and safe load. When I write Python shelf, what are the files with suffixes, dat and dir, other than key value stores, what other kinds of databases are there, blah, blah, blah. Write a function named replace all. Yeah, so more exercises that in pre-secondary shelf model to make a key value store that maps from a sort of string. Good stuff. I'm just skimming over these. Once again, I'm much less interested in these. The Markov chain ones were more interesting, but this is just kind of back to boring. Once again, great if you are starting off. You definitely should focus on these. But otherwise, whatevs. All right, that's the end of the video for now. Thank you so much. Catch you guys in the next one. Bye-bye.